Hello, David.
Good evening. Hey, Alexi, how you doing?
Hey, first time I'm
What
doing it from my phone because it's could pick up the time.
what time zone are you in?
It's 3 p.m. It's Eastern Australian, Sydney,
Oh,
Melbourne.
just,
Yeah, and it's even summer here.
oh, fun. It
Yeah,
is the opposite of what it is up here.
exactly. Plus 35 Celsius. Very much February weather. Where are you?
Colorado, so February is very much not a warm month for me.
Right. You have snow?
Uh, Not recently, but yeah, we had snow, I think like 2 weeks back.
It's like snows, then it melts, and then it's like all dirt and mud, and that's it. It's not like
Yeah,
Canada snow, right?
no. Well, it can be, but not this year. This year's been pretty light on the snowpack for some odd reason.
Yeah. No, we do have snow, but like, we have to drive a couple of hours during winter.
Mm.
Where is everybody?
So Dan mentioned a couple times that he had to leave early. I'm not sure if that means he's not coming at all or no, there he is. Never mind.
Hey, all, Dan joined.
Evening, Dan.
It looks like my conflict cleared, so I can't be here for the whole meeting. So it'll
Oh,
be
cool.
better.
Hmm.
I'm checking to see that did anybody have any opens to add to the agenda? I didn't see any replies come in since I missed something.
I did not comment on the mail, but I will have a bunch of questions.
Okay. Well, let's go through the first couple short items and then get into the discussion with that Matthew and David wanted to have. So the first quick thing was I was talking with Lucas earlier, and he was mentioning that he read that the CMA specification says that basically results are indeterminate if the device is not a D0 when you're doing CMA operations. And so I assume that implies that we also need to power up the device for every time we're talking to the DSM at all, for IDE, for SPDM, all of that. So I think it's a pretty minor change, but that's something I think we're missing today. The other thing that's in the spec now is a attention not needed bit on the DOE mailbox, which I'm not a not a huge fan of the design of this thing. Like it's a kind of a hidden power management requirement that's got added. Um, Lucas and I talked about it a bit, and we're the naive approach is that we're just going to teach the PCI power management core to sleep the device or set that not needed attention bit whenever the device goes to sleep, or whenever PM runtime says that the PCI device can go to sleep. But that might also need some discussion with PCI power management folks if they want to model it as something implicit or explicit. But it's kind of annoying because the all the DSM operations are in a completely separate path and agent than what the driver is doing for runtime power management. So stay tuned to that space. The other quick short topic was getting ready to cut.
Wait a second.
Actually, yeah, go back to that, sure.
So if that power management state changes, it means we sort of kind of like going through a reset and we lose the full state, or the OIE may not respond.
With the, well, I don't, at least for the CMA specification, it basically just said the device must be a D0 and good luck if you're not. Because I think config cycles can still work at D3 hot, but I'm assuming that the CMA requirement also applies to TDISP and IDE. So yeah,
Okay.
So it sounds like the device.
I'll keep watching this space then.
Yeah, it sounds like the device is allowed to, or yeah, the DSM is allowed to do something unexpected when you're not at full power. But the other aspect of this attention not needed bit is I think that means that I'm assuming that the DOE can. I mean, I think Linux will just assume that you can't set that bit if you and expect an ongoing transfer to keep going. So like if you're in the middle of something and you set that bit, kind of all bets are off. The DOE may totally forget what it was doing. So you better do it at proper boundaries. So that's what I think it means. Any other questions about that one?
Nope.
Okay.
Thank you.
So the next thing was just finally cutting a new branch of the staging tree. It's gonna be mostly pretty boring, from the perspective of mainly rebases on top of the fixes and everything that went in for 619. But then going to use that as a baseline to send out the next round of the phase 2 patches, which is kind of the finishing off the guest side infrastructure. I do want to get the sample driver able to go through, like start being able to do some of the IOMMU flows, IOMMUFD flows, so we can have a comprehensive TSM independent way to test those paths. I do know that some of the bugs that people found this past cycle were things that the sample driver could have caught. So I'm also going to beef that up to backfill those bug reports with tests that the sample driver can run. But that's the plan for this new staging branch. I'll cut that tomorrow, but then we can start talking about finalizing phase 2 and start landing some of the phase 3 early consensus patches, because like we had that discussion on Discord, and this will be, we can circle back to that discussion on Discord, but suffice to say that next staging branch, mainly just a rebase. I don't know if ARM if I'll be able to include the ARM CCA bits again, because those were 618. I don't think we have a rebase of those yet. So if the old branch merges cleanly, great. If it doesn't, I'll drop it. And Anish is aware. He said he'll follow up if we have to drop that one. Okay, yeah. Any questions about or patches you'd like to see or changes in the staging tree? Yulun has sent me a fix for something that was in the staging tree currently. I'll roll that in. So you might see some patches in there that haven't been posted to the list yet, but the plan is to get those immediately posted to the list, so we're not carrying anything in the staging tree that's not on the list.
Okay.
But it was just that one fix you sent me, right, Yulun? But I'll include that. I'll either fold it. I'll probably just fold it in and include it for now, and then I'll get the patches posted out after that.
Which patch are you talking about?
I think so. You had the fix, and then you had some, and then you had the interface report stuff that we want to start. The interface report stuff I'm going to push it out till later, but the fix. I'll find it I'll find it while we're going to the next topic, and then I'll send you a note to make sure we're on the same page.
Oh, okay.
Okay.
So
yeah.
in this IOMMUFD area,
Mhm.
we kind of have to start posting patches for IOMMUFD to map from what's that thing? GMMFD.
Yeah, the guest MFD to IOMMFD hookup is.
And I have like 1-year-old patch, which I posted as part of this 40 patch series year ago. And I looked at the review from Jason, and he's like, yeah, basically this is the way, but we'll need some cooperation with KVM and JMM, and we probably need some hooks when KVM does something to JMM memory to notify IOMMUFD about it. Has anyone looked into this, or I just hack something up, throw it out to make Jason annoyed and comment a lot and give us directions? Or I have something better?
I'm wondering if that should be like the first topic, the primary topic for our next meeting, to like just because even in that thread, like we have like Yulun has a way, you have a way, Denise has a way. Just get to some basic consensus among us first, and then go out, because otherwise, yeah, just so we're all kind of on the same page and speaking the same language is my initial reaction. I don't know what.
Okay.
No,
I can do homework before our next call and then annoy Jason.
Okay. Yeah, like we should all, yeah, live and die on the same annoyance of Jason attempts. Yeah.
Yeah, it's better 3 versus 1 than
Yeah.
1 versus 1.
Yeah.
The other thing I have question about is that phase 2, when we do this guest basic support, and that's the worst part, because whatever we do now is going to stick with us for ages, because it's for the guest.
Yeah, it'll take for 7 to 10 years. Yeah, that's the.
And so before I didn't have explicit PDI bind from the guest. Now I do, because we have some change in PCP firmware and all that. Now I wonder if I want to have explicit run from the guest to the host, because in my system, host does transition to run. It will ask PSP for that, but it's still initiated by the host. I need to extend my GHCB for that. And all this talks about device not working after config locked state. Kind of suggests that we're not there yet to, have unified approach to how we actually do run.
So, I guess I'm not understanding the difference. Like, so, locked.
How does run work on your platform?
Run is a part of accept.
So guest calls PSP and asks to accept, and then your firmware does the run.
Yeah, there's a GCI call to ask the host to put it into the run, to send the TDIS message to put it into the run state.
It asks the host. Or
Yeah,
the
it is a host puts the device into run state.
But from the guest perspective, why does the guest need to see the difference between accept and run?
Yes.
No, I don't think.
Right.
Yeah. Well, in our case, the thing is, if guest wants to do any guest request, it needs to provide unique ID of this binding of TDI to a guest. And every time you do a bind, you get new ID. And that's to protect ourselves from rebinding on the host between lock and accept. Right? So there is this ID which I need to get from hypervisor to the guest. Right?
Mm-hmm.
And so I need to do bind first on the host. Then I need to extract this ID from PSP and pass it to the guest. And then the guest will be able to do MIO config and enable DMA. So this extra step, so before I would go to config locked when I do, say, get info about TDI from the guest. And I cannot do this anymore because I need this extra step to get this ID because get info requires it. And this extra step is essentially binding in the PSP. Doesn't even have to change any state, I think. Maybe still config unlock. Anyway, I have this special extra operation. But you don't, right? What's your flow? Is your phase 2 posted somewhere? So you can just go and have a look.
It's not. Go ahead, Elon.
Yeah, I think recently we are considering some similar questions about it. That if you bind and you have attested, and before the guest accept and put the device into run state, host is possible to unbind the device and then modify something and rebind the device. Yeah, and that undermines the attestation.
But doesn't the interface report guarantee you that like the interface report you? I thought there's a nonce or some indication in the interface report, the one you're accepting, that you have to reply back.
No, interface report is pretty stupid. It doesn't have anything like that.
I thought that
just list of regions.
Yeah, I thought there was something that ties the attestation report, the attestation evidence you get to the accept, to the run flow. Like you have to acknowledge that yes, this is what I'm running.
I think
I'm pretty sure
attestation report.
Interface report will be the same from two different functions of the same SRIV device.
Yeah, the report cannot. The report cannot guarantee that it is still bind before you accept. But I think we are implementing some new mechanisms that the firmware keeps bind epoch index, something like that. So when you start the device, when you want to start the device, you talk to the firmware and you need to provide the bind epoch index to the bind to ensure that you didn't the host didn't unbind and rebind after you have attested the device.
You have a special request from the guest which says bind, and here is my unique cookie for this TDI.
Yeah.
You do have bind.
And
you have run?
And when you and when you run, you need to provide this cookie.
And when you run, it's still the guest asking hypervisor to do run. Well, accept.
The guest need to directly tell the firmware that I want to start and provide the cookie, and then ask host to do bind. The host can only successfully do the start when guest request the start. Yeah.
Yeah, that was the thing I was referring to. Yeah, like I got my wires crossed. Yeah, we need something that ties the start request to the evidence you got.
Yeah.
See, in my case, these are decoupled. Enable DMA and tell device to go to run state are different things. And enable DMA is what guest controls, and go to run state is what host controls. And now I look in the host that here is enabling DMA request. And that's like, okay, we probably can start now. And that's how I do it. So I don't have explicit run. So you do call, you request run, and you enable DMA in the separate steps, or enabling DMA is a part of your run.
Basically, you mean unblocking DMA at the
Yep.
at the hardware level. Yeah.
Yep.
Unblock DMA is a separate operation in guest, separate from run.
Yeah, I think in the discussion we're, at least I'm having trouble parsing out when you're talking about the steps in Durella. I think we have the same discrete number of small steps, but do those need to, can those all be encapsulated in our current TSM ops, or do we need PCI TSM ops, or do we need to break those down as separate ops?
Yeah. So right now we don't have run anywhere.
Right, we kind of do it as part of accept.
Yeah.
No, it's except in the guest, but on the host there is no such thing as run. There
Right.
is bind,
Right,
and there is guest request.
That's what I'm saying. Like the lock step on the guest. There's a whole bunch of work on the host, GCI, bind, all this kind of stuff. The accept step request on the guest goes into the TSM driver, sends the run command to the host, gets it back, and then does unblock DMA locally. All that happens in one call. So I'm asking like if we need more finer grained callbacks.
Right. If we stick to one callback, then my problem is that when I do unlock in the guest, and before that, say I have run, everything worked, everything enabled, secure, and everything, then I do unlock. So I call this TDI bind, the HTTP call, which ends up in doing unbind. What was the problem? Right. Before I do unbind, I want to disable DMA. Right? Do this SDT write thing and say invalidate IOMMU for this device. But in the host, when I get this message, I don't actually know what's being requested. Enable DMA or disable DMA, because this information is encrypted in guest message. So host can only see type of the message, and it's like about DMA, but not what's inside. So I have to convey this additional flag in GHCB, which I do. But when I come to guest request in IOMMUFD in the host, there is no place for this flag. There is only this scope, which I can play with. And say if scope says state change, then it's definitely stopping, or it's definitely running.
Oh yeah, no.
And if scope is different, then, but scope is not exactly for that. Right?
No, scope's not for that. Yeah. Okay. I took a note to come back to this because yeah, let's if we have some time at the end, we can come back to this. And because I want to make sure we have time to let Matthew and David do their.
And I wonder how you don't have this problem then. So if I could have a look at what you do.
Okay.
I mean, the latest stuff, because I keep pushing mine last couple of days to GitHub.
Okay. Is the but you don't need a. Well, yeah. I'll save my question to the end. Okay. I took a note on this. Guest request flag, but you're saying you want a guest request flag potentially to indicate that you're disabling that is bind. The way you unlock is by binding again, and this one you want this to be to stop DMA.
I mean, if we make run and stop part of guest request, then we need some information to give a hint if it's stopping or running.
Okay, I see what you're saying. Okay.
Another unrelated question I had.
Okay, well,
Yes, we now does.
was
Any?
I was gonna say let's bend that question to the end, and then we'll come back to it.
Okay.
Okay. Yeah. So David and Matthew, I heard you guys had a chance to connect a little bit and wanted to share some details about moving Lucas's work forward for the TSM case.
Yeah, so it's a combination of conversations I had with Matthew and you, Dan, about kind of what would need to be done to Lucas's patch set to merge it. And I think several of us are in agreement that there is a lot of stuff in the CMA portion of the patch set that will probably get some pushback from the kernel community, which would make it harder to merge. And the reality is that we don't need any of that to push the TDISP use case forward. Like a good about half of this patch set has no relation to the TDISP use case whatsoever. So we were thinking that it would probably be a good idea to get some sort of core SPDM functionality upstreamed that is independent of TDISP and CMA. And then we can work on our respective portions to use that core functionality to get it working for a use case. So I'm thinking that we kind of dissect Lucas's patch set, and really there's only like what appears to be 5 or 6 patches that would need to go upstream to provide us PDM support. Now there's a whole bunch of work that would need to be done on our end for the TDISP use case. Things like when do we want to do SPDM session establishment? How do we do it in a way that is generic enough that we have a framework for doing session establishment, and each of us implement our own equivalent of the TSM module hooks for that, so that we're not putting any sort of everyone has their own module specific functions that are just basically hooks into this framework.
But that's my question. Like we see none of on our side. I think in all cases we see 0 of the SPDM. Like I mean, like we see the effects. Like we see transcript. Maybe we can get evidence that there's SPDM there. But in terms of like the protocol running things, we're just calling an ABI like connect. We call it connect, and that's doing SPDM behind our back. We actually don't even know or care if it's SPDM there. We just ask the TSM, hey, I'm assuming you know how to establish a secure session to this. It could even do something proprietary if we wanted to.
But that's not how the TSM works, right? The TSM's the only part that the TSM plays in the SPDM session, at least in the TDX perspective, is holding keys, right? It's still all orchestrated by the host. The host has to know when do we start the session, and to sign a message, it will then ask the TSM, "Hey, can you sign this message for me in a key that's tied to the SPDM session?" Something like that. But the reality is the host still has that. The host is the only one who has the DOE mailbox and can send these messages to and from devices.
We're the only ones that have the mailbox, but like in the TDX case, firmware is running the entire SPDM protocol, and it's basically just saying, "Hey, you said you want to establish a session. You call this ABI. This continue to call this ABI, and we will, and the TDX module will say send this message over DOE." But as far as Linux is concerned, all it's doing is it's just a pass-through pipe to pump messages over DOE mailboxes. It doesn't know anything about the contents besides the TSM asked me to send this to you. Oh, I got a response. Here you go, TSM. So like I'm not even sure we would use any of if any of Lucas's SPDM library would apply to the TSM case. Am I off base?
My understanding is that how it is in the newer version of TDX? Because that's not how it was originally. Like all the flow diagrams I saw originally was different.
What Lucas is doing is CMA part, which is SPDM, like plain SPDM, non-encrypted. So you could actually parse it and see what's going on between firmware and device. And maybe extract certificates and measurements, because it's all like in plain.
Yeah,
I mean, first few chunks.
Yeah, we could do a sniffer for it, but we're not actually going to use that flow. Like my understanding.
Maybe if we want to present it to host user space, then via that netlink and stuff, we could do that in the same way CMA does.
But do you have that for access on
Nope.
on TIO? No, you don't, right?
No, you can sniff on traffic, and traffic is not immediately becomes encrypted.
Right. Yeah, no, we can infer that an SPDM thing is there, but all of the protocol logic of what to establish a session, what keys to run, what messages to send, that's all decided by either TIO firmware or on TDX we have this like extension component called TPA.
Yeah.
That does that.
So how do you get that out of the TDX module then? Because from an actual attestation perspective, there's a lot of information that needs to be gathered from the SPDM session for you to be able to do anything for attestation for that device. Like you need the VCA for calculating the hashes of the transcripts. You really kind of like if I want to request a single measurement, how do I do that if the only thing you're giving me is this message transcript back?
Well, like both TDX and like all of them have an info collection ABI that's supposed to gather all that goop for you, but it's like it comes back in one big information structure.
Yeah, I think the reality though is SPDM measurement messages are not that simple, right? Because you can basically say, give me this measurement, unsigned, unsigned, unsigned. Finally get a signed measurement back, right? Like, are we really not allowing the guests to request individual indexes from a device measurement? Or is the interface to the guest just going to be, here's a device report, good luck? Because a lot of what we do assumes that we have access to like be able to actually, send real SPDM measurement requests to the device.
Why do we care about accessing individual measurements if you can have the whole block and then find your measurement in the block, in the blob? It's not like gigabytes of data. It's not even kilobytes, or maybe a few kilobytes.
It might get bigger when we have other form of encryption like post-quantum computing. So we can't assume that those measurements will be small or the results will be small.
Because PQC keys alone are pretty substantial, right? And you're going to need certificate chains and whatnot that are PQC compliant, which is more data than the measurements are going to be. So there's a lot of data that potentially comes over.
But David,
I think like a megabyte. It's just not that big. I don't.
Well, it's not that big. It's not that big right now. It could, but I think it's going to be bigger with post quantum and all these other kind of things, and dice and all these different formats. It could get bigger. But like on TDX, there's a SPDM device info structure. You say, hey, TX module, give me the SPDM device info. And I think that's the transcripts into the measurements. I don't think. You don't correct me if I'm wrong. I don't think we have fine grained control of just give me certain measurements with different signings and things.
On the initial bind, I think no, we cannot do that. And I think when you have bind, maybe we can do some recollection, and we can input some parameters from guest to recollect these informations.
Okay, so the plan is not actually to expose SPDM to the guest at all, really, other than as just a blob of data.
It's a
No.
blob. Yeah, like you can the module caches the initial transcript at bind
Mm-hmm.
at connect. Later on, you could say I want you to give me that same thing again with a guest supplied nonce, but it's still coming back as TSM specific data structure format. I mean, it's an envelope that might have SPDM kind of format stuff inside of it, but there's a TDX version of that. There's a TIO version of that. So the kind of fine grained control that but I agree with the premise that we want the netlink interface. We want the kind of the how to package it up into something that crosses the kernel user space boundary. But in terms of a lot of the controls that Lucas has built for like specific measurements with or without verification, all those decisions are hidden from us.
Interesting. It was my understanding that the host still orchestrated it. It just was using the TDX module for signing and verifying messages based on the keys that it had, right? Because the actual encryption is protected through the IDE stream. I guess there's also secure SPDM messaging, but so
Yeah.
the reality though is these interfaces need to return standard body formats, right? We can't just say here's an Intel blob with no integrity on it, because no one's writing a verifier for proprietary formats like that. Everyone's using CBOR and all these various standardized formats for evidence. So it has to come back in something that's standardized.
Correct. I mean, inside the kernel, it might be the TAO format, TAO wrapper, and the TX wrapper. But once it comes out to user space, we want that to look like a format that you could verify with whether it's CMA or TSM or either one. Yeah.
And I think in that regard, Lucas' batch set has kind of showed us the way. We're just going to have to extend it for measurement. So he's done it for certificates, and what's going into the API. So his API is taking very structured information and turns that into DOE messages. So what we need to do is get an operation that would be either DOE or something else that would be platform proprietary based on how SPDM information gets into the TSM. And what's coming out of it should also look like something very similar to SPDM messages. That's the only way that we'll actually get through this in a standard way.
Well, AMD PSP firmware returns measurements as a SPDM transcript, exactly as it's described in the SPDM spec.
Yes. And that's okay.
And you just assume that you're going to grab everything every single time, basically.
Yeah, right. That becomes a platform-specific thing. I mean, however it works on AMD will be different on ARM and Intel. The interface has to be flexible enough to accommodate what the platform can do.
I would think Intel return same transcript, maybe with a different header. It's a minor detail.
Yeah, the data structure that the Intel format comes back as, you get a combined thing that has like the heartbeat, the TDIS version, all the certificates, all the measurements, and the transcript in one thing. So Lucas interface allows you to request different pieces of that. So like we might cache this whole thing, and then the netlink interface says, "Oh, I just want that measurement," or "I just want this thing," and we could parse it. We could get fancy and parse that out. But in terms of but that doesn't seem to really move us towards our goal, which is really we just want to get this whole thing out, and maybe we can define a TSM format for that, which is hopefully the ARM, AMD, Intel things are all pretty close, and we just say here's the TSM format, and it comes out in a way that user space can just say, okay, yep, this will work for everybody's architecture.
Yes, because we're working with the TSM protocol, so might as well model the interface based on that. There's no point in trying to be fancier than that.
Yeah, you're right.
It's also the only way that we're gonna be continue to be compatible with the SPDM protocol in the future releases, and it's also the only way that we can exploit SPDM to its fullest without constraining any platform or any architecture, I should say.
Well, I mean, I'm with you up until the point where you say like not constraining SPDM. Like we can't see SPDM. Oh, we only see these ABI responses.
I agree. Okay. But you're
Okay.
still getting SPDM information out of that blob.
Yes. Okay, we're on the same page.
So there's no point in trying to come up with a different format. The format is given to us by SPDM. It's, in my opinion, the easiest way to proceed.
Oh yeah, no, yeah. I'm not saying that we would read format SPDM, but this data structure has SPDM information as certificates. It has other device information that we need to parse out, but that's pretty straightforward. So yeah, I think we're in violent agreement that we want to get the parts of Lucas's patch set that present SPDM information, and we want to plumb TSM into that subset and forget the rest. Yeah.
Exactly. And the plumbing
is
architecture specific.
So then there's even less of his patch set that's needed. It's literally 3 patches then. Expose certificates in the sysfs, and that has to be rewritten to plug through a TSM and get the cert chains out of whatever TSM response there is, and then plumb the netlink interface he has to be TSM requests instead. If we don't care about anything SPDM in the kernel, if we're saying the TSM will handle everything SPDM, the only thing we need is an interface to talk to the TSM and to get a response back and populate it to sysfs, then there's almost nothing in the patch set that you keep.
Right. The sysfs part worries me because in Tokyo, the community was quite adamant that they don't want a sysfs interface; they want a netlink interface.
I think.
Yeah, but reading cert chains out of sysfs is reasonable, right? You can read that whole blob of data in one go. That's static. The reason they didn't want a sysfs interface is with the whole idea of if you're going to send flexible measurement requests, then poking and prodding at a whole bunch of sysfs files and then punching the final one to say, here, now go send the message and give me responses back isn't a good interface. But to get like a large blob of data, like the certificate chain, which is going to stay static for the device, out of sysfs seems reasonable.
Yeah, I think Lucas was they come to the same conclusion that there is still a role for sysfs for static big things, static binary things. But if it's anything like anything like a request response, anything like a do the same request but set this flag, then netlink. It might. So maybe it's those 3 patches plus the what does the measurements ABI look like? Because Lucas hadn't done that yet, so that part's not even in his patch set. I think for the TSM case, it all comes like Lexi. When you get that information, isn't that whole thing signed by the TSM? Certificates, measurements, and transcript as one kind of signed object?
No, it comes as 3 different blobs.
Oh, 3 different blobs. Okay.
Neither of them is signed, except measurements have that last message.
Okay.
It's signed, which is signed.
So that makes, I guess that sounds like it makes it easier. Like we just need to pump those out. So I'm going to point Lucas to listen to this recording. Hi Lucas, and yeah, see if we can start a conversation on the list. But for what I think he's open, to saying, if you want to pull some of the stuff out, I think he'd be open to that.
Well, I think the reality is that Lucas's patch set is from a perspective where the host kernel is aware of SPDM and cares about it. The way we're doing it for the TSM, it does not care about SPDM at all,
No,
other
yeah,
than
but
as a proxy.
right. I mean, what I'm saying is like the netlink, the cool things you're doing with netlink that are kind of SPDM independent. We can grab that.
Well, the only thing is the YAML file for Netlink that would be probably interested in is just the get measurements. The rest of it is not particularly relevant to the use case unless it's just pull the whole blob out.
Is he getting the transcript in netlink or sysfs?
Let me take a look. SPDM challenge auth request, endpoint info request, SPDM measurement request, key exchange response, SPDM finish. Those are the definitions of those response codes. Where's his actual functions in there? Multicast groups, operations list.
Because I think you broadcast every time something happens to the transcript, which is something we can't do.
Yeah. So he does have something. There's an attribute there for the transcript, so he does get it back over Netlink.
Okay.
Yeah. Yeah, I don't see where like normally there's a definition of what the actual I guess requests that are being made over Netlink are, but I don't see that here. So maybe you're right. Maybe he doesn't actually have the that portion of it.
No, he mentioned
operations. Oh, there's a list operation. There it is.
I think he mentioned somewhere that he's doing measurements is next up when he's not distracted.
What are you looking at? Some patches somewhere.
Yeah. Let me give you the link to it real quick. I just gotta find it real quick. This one. This is patch set. That one. Definitely not that one. Here it is. So this is the latest version that Lucas has. At least the one that I'm aware of.
Yeah, that's also the one I've looked at.
Yeah, that's the one you sent me. So.
Okay.
Yeah, and
I think it's rebased on 619 RC1. I think. So it's probably his latest.
Yeah. Commit says of January 11th, so not too long ago. But yeah, if you read through this patch set, I guess there are still some open questions on our side though, right? Because even if the TSM and in our case the TPA is managing the SPDM session, something on the host has to say now it's time to actually start that session. So we need to come to an agreement on when we're going to do that. Is it the first time a TDI is assigned? Is it when the device is probed?
No, at connect. So we hit the button. So a script or something hits the button that says we want this device to be secure. It could either, and so that's a sysfs operation to start that process.
Yeah, but what do you mean by that though? Like what entity would be pushing the button? It would probably be something where the first time you assign
host user space.
Host user space.
Libvirt daemon.
Yeah, so it's when libvirt assigns it as a secure device to a VM, basically. You'd have it do it then.
It's getting noisier where we're mass from. Keep the stay on mute.
Okay, so this patch set seems like it's much smaller than I'd originally thought. since I thought that we needed to have a bunch of the SPDM moving parts from the patch set retained. In reality, it's just a netlink socket and exposing certificates over sysfs, essentially. Is the only thing we'd retained from Lucas's patch set. And even then, we wouldn't retain the patches as is. We'd have to retain them with proper plumbing into the TSM.
Yeah, like there would be a set, like, I mean, the plan has kind of been like, oh, Lucas will go first, and as we've seen, like the TSM stuff has landed first. So depending on whether he circles back and finishes that off, or somebody else grabs it and does the TSM thing, I'm guessing that the TSM stuff can go first because it has less to land.
Yeah, I'd imagine the TSM stuff will land first. Okay. So does the guest directly talk to the TSM to get the measurement, or does that have to go through the host to do it?
So I'm assuming that we're going to it'll be the same interface from an API perspective, but we'll have a kind of a guest version and a host version. Like the host version can see stuff as a result of the Connect response, and they can start publishing stuff on the host side. The guest will also kind of implicitly do a info collection event at lock time. Probably would also allow it to be recollected at will over netlink, so that the verifier can supply a nonce. But that the data coming out of that would be TDI specific in the guest side and physical functions on the host side, because we get the obfuscated interface report and other things on the guest side.
Okay, so I guess that changes the plan.
It'd be good to kind of have a diagram showing all the pieces together so that we can follow along, Dan or David, right? So we're talking about several components here, so it'll be good to kind of see where we want, or which component wants to do what in this picture.
Agreed, yeah. And so to kind of come to a consensus point of, hey, we need to look at pulling some of the pieces out and summarizing it into some architecture boxes. Any other questions for this meeting about that?
No, I don't think so.
Okay. So then, because otherwise, yeah, if we have these last 5 minutes, I would go back to that question Alexi had.
Right. Two questions. With all this stuff, safety IO, we need, because now we have to do RMP checks in IOMMU, and RMP is that hardware firewall to prevent wrong memory accesses, which is reverse map table thing, AMD specific, but IOMMU checks it. So when we change any mapping or lower priority in the guest, we have to flash IOMMU caches on the host. So I need some sort of API in the guest, which I call now, like, there is a helper called device underscore cc underscore accepted underscore any. And it says if there is any TIO device, then we do this IOMMU TLB flashing thingy. Do you need any of that on Intel? How are we gonna do this? Because right now I have static counter, which I increment every time we accept device and decrement when we reject. And Borislav says, like, maybe we want to have a list of accepted devices because later on you may want to do some group operation on all accepted devices, which I don't at the moment. So do you have something like this in the works? Or planning?
You mean when the device is reaccepted, you have to, before you can reaccept it, you have to flush the RMP?
No, I mean when I change some permission on some page, lower priority, say it was read write, and now I'm making it read only. Things like this, which Linux doesn't normally do, but with this VSM in the picture, this is going to happen more often.
Guest permission or host permission?
Yes. There are moments when we want to flush caches and guest does something, and it relates to RMP check. Or we make page was private and we make it shared, or vice versa. We want to flush caches when it becomes private, because IOMMU remembers the result of RMP check.
Take a note. I'll take a note to look. Nothing coming to mind about where we need that flow. But like, is this? But this we would hit this even in the case where we're not allowing the device to, like, is it only for the private to shared conversion?
It's private to shared, or read write to read only, or lowering the MPL level. The MPL is the thing, and I don't know if you heard of SVSM, Coconut, this kind of thing. When you have different privilege level software and the guest, and one is this super firmware called SVSM, and Linux kernel runs in PMPL2. And SVSM runs in PMPL0. And when page moves from 0 to 2, that's lowering privilege as well. And we want to flash IOMMU caches for that too. It's not about translation. IOMMU translation is about RMP check. But still, need to talk to IOMMU about that.
Would the SVSM know about this? Like, if you
SVSM will have to do this dance if it changes priority. It's either a special instruction or DHCP extension. But something guest initiates and host executes or hardware. And we don't need to do this if we don't have any trusted devices in this VM, because we won't need to flash RMP checks from IOMMU.
Yeah, well, we don't have an RMP on the Intel side. But would this just be something that where can the SVSM intercept or see? I guess your TSM could notify SVSM, say, hey, SVSM, I got a device here now connected. Remember me if you ever have to do any permission changes, and then flush this.
I mean, I don't wanna do this dance every time the priority on the page changes in the guest. So I was wondering if I could have this flag, global flag, saying we don't have to do this.
You mean to batch it, like, don't you have to flush the entire? It's flush the entire RMP when any page changes for all devices that are attached.
In the MMU, yep.
Okay.
I'm not sure. You need some explicit flags because why you need explicit flags? Is it because that the command is that the guest send to the firmware is encrypted and the host cannot get what the command is? Is that the case? So I mean that if the host TSM driver could fully understand which command it is from a guest, then it could do something accordingly.
True.
Then why
The
we
question is whether the guest sends any command or not. Because if I do it on every page state change, that's going to be annoying, and it's slower than it has to be. It only makes sense when you have trusted devices in the guest. The host side, easy. It's the guest side which needs to decide whether to call host or not, or whether to call this new instruction or not. So it's purely in the guest. And I have like simple vulgar patch to implement this flag. And I'll post it just right after the call. And it's in my staging tree. So you can look and barf and propose something better or a list of devices. Maybe you have a function to run through all accepted devices every so often. And I could use that. If the list is not empty, then that's my flag. But if you don't have anything like this, you can just do it as simple as possible now and extend it later. Okay, you don't have anything like this now.
Yeah,
And the other
so.
question was if you do 2 meg pages or not in IOMMU, in nested page table, or 4K, and you leave 2 meg for later.
Yeah, this is I don't know if you've been following the guest MMFD calls. Like, there's a whole saga about large pages and
yeah, I know. I rebase all my trees on top of my growth trees, which do in-place memory conversion for 2 meg, for 4K, and it's always complication. And I tested 6.17 with huge pages. And now IOMMU is reworked, and Jason is pushing me. Like, don't do this, don't do that, and it's like horrible design in MDN. And I wonder if I give up to make pages for now, or like a couple of years till hardware improves the way he likes.
So in the phase kind of distinction of what I've been tracking in that kind of maturity map, 2 meg pages, performance enhancements, advanced error handling, that was all post phase
5.
That was all phase 5. That was all after we got all the 4K stuff done and we could fully accept the device.
It doesn't say we cannot start working on it now. So.
Oh yeah, no, we can start working on it now, but like at least on the TDX side, where we're at is we can't even get 2 meg pages going without devices. So we're far off from even thinking about it for
right. What about devices? Have you tried?
I assume on device side, Intel TDX may not have much things to do because Intel TDX secure IOMMU shares the page table with the secure second level page table. So I think as long as the secure second level page table secure KVM MMU is correctly established, the IOMMU side it would be okay.
Okay, good.
Yeah, so just a small matter of hundreds of patches to get to that point.
Right, okay. That's all I got today.
Okay, so last thing was, you said, hey, can we move this meeting 2 hours earlier? That works for me. Does anybody have an objection to moving this meeting 2 hours earlier?
1 hour. Oh, I'm okay.
No, I mean, let people say what continent they're from. There is no one from Europe, right? And this time and 1 hour before works perfectly for Australia, India, and US. Both ends, right? Or it's not too late in New York. So
yeah. So Elon, does that work for you?
Yes, definitely.
Okay. And David?
Alex and I are in the same time zone, actually.
Okay. David,
Yeah,
I think it'd be okay.
I can make it work.
Or
It's
is
right
it?
around the kid's bedtime, but I can make it
Oh,
work.
okay. Well, no, I mean, like, I want it to work for everybody. So if that's, I also, what about 1 hour earlier? Well, I mean, well, Alexei, you were suggesting that just to kind of be nice to us Pacific time zone people. I'm okay with it the current time. So if you needed to move, let me know. But I think if I'd like David not to have to tell the. I don't want David kids growing up saying like, what, I hate to teach this.
I could just
Okay,
let him
then
go to
keep
bed
it
an
this
extra
time.
hour later.
Yeah.
It's easy enough for me to just let him go to bed an hour later.
Okay, you decide.
Okay. I think we can leave well enough alone for now, and I think we'll be okay.
Okay.
Thanks for the offer. Okay, I will.
And it will move 1 hour earlier and 2 hours earlier later this year anyway. So.
Oh yeah, because
The DST? Switch?
Yep, it'll switch. Yeah, we'll figure that out.
Alrighty.
Okay, I will talk to you guys the next one. Yeah, and then but I took a note to send you. We're gonna figure out this whole bind consistency, and do we need to plumb that? Like, if you have a solution for that, and I think a TDX solution for that, we need to think about how do we associate the run with the last bind.
Right.
Okay.
Cool.
Hey Dan, can you send me the links internally on where I can get the latest versions of the TDX documents?
Yes.
Because I guess the ones I have are outdated because they're not. My understanding of the way things work and your understanding of the way things work are not aligned. So I need to find out why that is.
Okay, no worries. Yeah. This was a whole saga about like, please hide stuff as much as you can, and so that was the big change from the first documents to what we have now.
Okay.
Okay, we'll talk to everybody next time. Thanks.
Thanks. Bye.
Bye.
Bye.